Good morning, Townview. So today we're going to be talking about solutions. So at the top of your page, you're going to write out the word solutions. And today's lesson is going to be mostly vocabulary. And then I'm going to give you guys an assignment that that you need the vocabulary in order to get. All right, so let's go ahead and move on. So what is a solution? A solution is made of two things. It's going to have a solute, and then it's going to have a solvent. The solute is going to be the substance being dissolved. In this case right here, it's going to be the Kool-Aid. The Kool-Aid is your solute. And then your solvent is the thing that does the dissolving. In most scenarios, that thing is going to be water. So the solute is going to be the lesser quantity, the thing that you have less of. And then your solvent is going to be the thing you have more of. So in the case of chocolate milk, what is your solute? It's going to be the chocolate syrup. And then what is your solvent? It's going to be the milk. So the solvent is the thing that there's more of. The solute is typically the thing that you have less of. So these are definitions that you guys have seen before. I just wanted to run through them real quick in case you forgot them, because the whole unit that we're about to get into is all about solutions. All right, I'm going to move on, and these are on the next page. So I kept them on this page in case you're still writing them. So next term you guys have is solubility. So what is solubility? It's how much solute you can dissolve under certain conditions of temperature and pressure. So solubility, that's how much solute you can dissolve. And that actually depends on the temperature of your solvent, also the pressure of your solvent. There are other factors, but we'll talk about them in a minute. But one thing to know about solubility is it does change. Okay, let's move on. Two more terms here, also terms you've seen before. So the first one is going to be miscible. These are things that will dissolve into each other. So another term for this is soluble. So if they will dissolve into each other, they're called miscible. They're also called soluble. Just words that you need to know when you see them in a question. Next one is going to be immiscible. These are things that are insoluble. So up here we have things like, I guess, alcohol and water, or salt and water. You put them together and they do dissolve into each other. They form one substance. And then immiscible is going to be something like sand and water. You put sand and water, it's just going to fall to the bottom and they're not going to dissolve into each other. Okay, let's move on. All right, so here we just got a quick question. So which of these is going to dissolve faster if we put it in water? So here we have granulated sugar, and then here we have sugar cubes. Which one is going to dissolve more quickly? Why is it that this one dissolves more quickly? What's that? Okay, they're not connected, but what's another reason? Why does this dissolve more quickly than this? All right, so we'll talk about the answer on the next page, but here's another thing. So if we wanted it to dissolve faster, so let's think about the sugar cube. We put the sugar cube in some water and we want it to dissolve more quickly. What can we do to make it dissolve more quickly? Okay, so crushing it, turning it into granulated sugar. What's another thing we can do to make it dissolve more quickly? Okay, so raising the temperature of the water. Is that going to make it dissolve more quickly? Okay, what's another thing we can do? There's one other thing y'all haven't mentioned yet. When you put sugar in your coffee, what do you do to make it dissolve? Okay, stirring it, good. So those are the three that you guys need to know. So when we're dissolving a solid into a liquid, there are three things that are going to make it dissolve more quickly. So here's what you're going to want to write on your page. So solids dissolving into liquids, these are going to be the factors that affect solubility. There's a total of three. I included the fourth just to tell you that it doesn't really affect this one. But the first one is going to be surface area. So when we were talking about the granulated sugar versus the sugar cubes, the reason the granulated sugar dissolves more quickly is because more of it is exposed to the water at any given time. So when you put a sugar cube in water, the outside surface area is what's exposed to the water, and that's the part that's dissolving. Can you dissolve what's at the center right away? Yes or no? No, you can't. You got to dissolve the outside first. When you're looking at granulated sugar, it's all exposed to the surface of the water, and it's all dissolving more rapidly because of the increased surface area. More of it's actually interacting with the water. The next one is stirring or agitation. Agitation is the word that they're going to use on the test, so you need to know what that means. So if you stir something, what you're doing is you're causing it to dissolve more quickly. So if you put this sugar in there and then you stir it, you're just exposing more of the sugar to the water, which makes it dissolve more quickly. So stirring or agitation. Another thing that would apply is like shaking a bottle. All of that counts as agitation. And this is true specifically for solids dissolving into liquids. All right, so the last one is going to be the temperature of the solvent. When we increase the temperature of a liquid, what do the molecules start doing? All right, so they move faster. When the molecules move faster, they cause the solid to dissolve more quickly. It's because the molecules are moving faster. So a higher temperature will allow more solid to dissolve into the liquid solution. So you know all of these things, but on the test, what they're going to ask is the type of question you're most likely to see is which of these factors does not affect the dissolution of a solid in a liquid? You'll need to know that pressure doesn't affect it. So pressure has no effect here. That's one example of a question. Another example is you'll see a bunch of false statements with one true statement. So the last one we have here is pressure. Pressure has no effect. So if you pressurize a container, it doesn't make the salt dissolve more quickly. It doesn't make the sugar dissolve more quickly. Pressurizing the container has no effect on solids dissolving in liquids. All right, let's keep going. Now we have the so gases dissolving into liquids. So on the last page, we had solids dissolving into liquids. This time we have gases dissolving into liquids. So for gases dissolving into liquids, a lot of this stuff changes. And that's most likely what the question is going to look like. So they're going to bring in some of the factors that speed up gases dissolving in liquids into solids dissolving in liquids, and you'll have to be able to identify what's what. So let's talk about these one at a time. So surface area. Is there a way to expose more gas particles to a liquid? Yes or no? No, because they're already separate from each other. Gas molecules, there's no interaction between them, so they're already separated. So surface area. is not has no effect on gases. That's one thing to know. Next one is stirring and agitation. Let's say you have a bottle of soda. If you shake it, is more of the solid going to dissolve into the gas, or does the gas come out of the solution? So when you shake a bottle, what ends up happening is the gas escapes from the liquid. So this has an opposite effect on gases. So gases can dissolve more easily into a still liquid. Next one is going to be the temperature of the solvent. So if you want more gas to dissolve into a liquid, you want the temperature to be low. So higher temperature decreases the rate of dissolution, which means hot water is not going to be as good as holding gases as cold water. And it's everything to do with the movement of the particles. So the water molecules, they're going to be moving very slow. When they're moving slow, the gases can sit with them. They can dissolve in them. But when the water molecules are moving very quickly, that's when they start releasing the gas molecules, and then the gas molecules escape from the liquid. So increasing the temperature of a soda is just going to cause all the CO2 to escape. So if you have a cold soda versus a hot soda, the cold soda is going to stay carbonated longer, assuming that both cans are open or both bottles are open. So higher temperature decreases rate of dissolution, and gases, they dissolve better in a cold solution. But those are both the same statement, just written out different. All right, so the last one is going to be pressure. So higher pressure increases the rate of solubility of gases. So here we have 3 containers. In this one, so think of this as, well, they all have the same amount of liquid. The only difference is the amount of air that they have. In this one, you have the most amount of air. Here you have the least. Well, both of these are the same. The difference is just equilibrium. So here you initially compressed it, so you brought the piston down. And if you let it settle for a while, these gas molecules that are floating around in the air, they're going to go into the water, creating a more fizzy solution. So think about like soda bottles. When you open them up, they're always pressurized from the beginning. So they add CO2 to pressurize the container. That causes the gas molecules to stay inside of the liquid. So the big differences between gases and solids is so surface area only affects the solids. It doesn't affect the gases. And pressure does not affect solids, whereas it's very important here in gases. And the other two are just opposite of each other. So solids dissolve better in hot water. Gases dissolve better in cold water. Agitation will cause more solid to dissolve. Agitation will cause less gas to dissolve. So a lot of the things are opposite of each other. But these are the rules, and we should have them all down. Any questions on solubility? Okay. So everything about the solids and liquids, you already know that. Just keep in mind that gases are the opposite of what you already know. All right, so we got 3 more terms for you. So the first one is going to be unsaturated solution. An unsaturated solution is a solution that just doesn't have enough solid in it. So if I have a cup of pure water, you can dissolve anything in that cup of pure water because the pure water can absorb a lot of that stuff. It can dissolve a lot of that stuff in it. So it can, if it has nothing dissolved in it, so looking at this chart, anything from here all the way to this line right here, all of this is going to be unsaturated. So think of it like a drink that just doesn't have enough Kool-Aid. It feels diluted. It feels, it doesn't taste sweet enough. It just doesn't really taste good. Next one we have is going to be a saturated solution. So a saturated solution is anything that's on the line. So anything that's on this line, and for you guys, this is what your chart should look like. I would draw this. So anything below the line, all of this is going to be unsaturated. When it's on the line, that's going to be saturated. So what does saturated mean? That means it's currently holding the maximum amount of solute possible for that particular temperature. So we already talked about if we heat up something, we can cause it to dissolve more quickly. But not only that, we could also get more of it to dissolve. So let's say we're looking over here at potassium nitrate at 30 degrees Celsius, we can dissolve exactly 22 grams of potassium nitrate. Now, if we increase the temperature to 40 degrees, we can dissolve about 38 grams. So increasing the temperature also increases the solubility. So more will dissolve at different temperatures, less will dissolve at different temperatures. And not all the lines look like this. You'll be looking at these charts very soon. But for now, that's what you want to know. So increasing temperature will increase the amount that you can actually dissolve. And if something lands on the line, for example, C, what kind of solution is C? What kind of solution is this? That's going to be a saturated solution. Now the next one, this is where it starts to get a little bit confusing. So what about A? What kind of solution is A? It's actually not a supersaturated solution. So think about sugar and water. You put sugar in water until it reaches saturation, and now you're at saturation. What happens when you add another scoop? Is it going to dissolve? What does it do? What does it do? Where does it go? It just falls to the bottom. Let's say you taste it and you figure out, oh, this tastes really sweet, really good. What's going to happen if you add another scoop? Will the taste change? Yes or no? Why not? Because the water can't hold anymore. So if we look at A, basically A is sitting at 15 degrees, and at 15 degrees, we can dissolve 11 grams of potassium nitrate. Now, what happens to all this stuff? Where does it go? It's just going to sink to the bottom. So what kind of solution is A? What kind of solution is A? Is it unsaturated? It's going to be a saturated solution. So because it's on the line, it's holding as much as it possibly can, and then all the remainder just falls to the bottom. So here's the question that you're going to see on the test. The question is, how do we create a supersaturated solution? So what is a supersaturated solution? This is a solution that's holding more than the maximum amount by being heated and then cooled. So has anyone here ever made simple syrup? Anybody know how to make syrup? So syrup is just sugar and water. So you take 1 cup of water, and then you take 2 cups of sugar. So if you take 1 cup of water and you put 2 cups of sugar, it's not all going to dissolve. But if you heat it up, it is all going to dissolve. Because what happens? As we increase temperature, we increase the amount that can dissolve in that particular liquid. Now, here's what a supersaturated solution looks like. So let's say we put 50, or no, we'll go with this one. We put 45 grams of potassium nitrate at 15 degrees C. We know that 11 grams of it dissolves, and then the rest of it just sits at the bottom. What's going to happen when we heat this up to, let's say, 60 degrees? What happens to our solution? What does it become? It becomes unsaturated. So for a second, it becomes saturated when it reaches this point, but then as soon as it passes that point, it becomes unsaturated. And then we just let it cool. So it becomes saturated, and then we cool it back down all the way to 15 degrees. What happened at this point? What kind of solution do we have now? Now we have a supersaturated solution. So to make a supersaturated solution, you have to heat it and then you have to cool it. So let me show you another example, another simple example. So over here, what kind of solution is D? It's unsaturated right here at 48 degrees. What if we cool it all the way down to 5 degrees? What kind of solution is this? It's going to be a supersaturated solution because it's not going to fall out of the solution. The solid is going to stay in the solution. But here's what we wanted to get from this page are the definitions. We're going to come back and talk about the saturation of these solutions, how to create these solutions. But for today, I just wanted you to have the definitions. So let's go ahead and take a look at today's assignment. So let's all hop on Classroom. All right, so when you get here, you're going to have a simulation, and then you're going to have a PDF assignment. So you and you're going to be working with your neighbor. One of you is going to open up the FET assignment, and the other person, or one will be opening the simulation. The other person opens up the assignment, and you guys are going to be working this out in your journal. Now, one thing I want y'all to notice, this one's very simple. This whole thing. So here you have your probe. And when you put your probe in the liquid, it's going to give you the concentration.